Wow, I didn't realize we were recording. I mean, I knew we were recording.
I mean, yeah, you're making me have to make a lot of choices here in the edit. I'll say that. Oh.
All right.
From ScienceSortOf.com, you're listening to Science Sort of.
Hello and welcome to Science Sort of. You're listening to episode 302. I'm your host, Ryan, and joining me to talk about things that are science, things that are sort of science, and things that wish they were science, centered around the theme of AGU Part II, Dune or Do Not, There Is No Dry Ice, which may be one of the more convoluted themes we've ever come up with, but joining me to discuss the convolutions and the reasons for them is Patrick.
Hello there.
And Charlie.
Hey, guys.
So neither of you were able to attend AGU this year, but I went, and Abe and I went and tried to cover it to the best of our ability. I definitely always feel very intimidated at AGU as covering it as press because there's like real reporters there.
Right.
There's like people from actual news organizations, but I'm usually one of the few people walking around with a microphone. It's like everyone either has a full production crew with their camera and lighting and all that stuff, or people are just taking notes on a pad and paper and then writing these amazing stories, and then there's me right in the middle just with a microphone trying not to look like a doofus. Did you ever go to AGU for science reasons, Patrick, or were you mostly just going because it was nearby and when we lived in the Santa Cruz area?
I've been at least 2 times I can remember where I presented. Yeah, so I've been for science reasons. I just always felt like you just got lost in that meeting, though.
It's huge.
It was so huge, and by the nature of my science, I was always kind of on the border of being super relevant there or not. I feel like everybody actually feels that way, whether or not they are, just because there's so much stuff going on. It was never my favorite meeting. It always just felt like overwhelming.
Yeah.
But it's the meeting when it comes to like earth science. So kind of like if you can make it there, you can make it anywhere.
Charlie, I imagine this was your meeting for a while, like your main.
Yeah, my main
event?
meeting was Lunar and Planetary Science conference down
this is a little too broad for you.
Down in Houston, but I would go to this every year and present throughout grad school and most of my postdoc days, mainly because of convenience, because I lived within biking distance of Moscone Center in San Francisco when it was held there. Since it's moved around, I've had less compulsion to go because, again, it's such a broad meeting that I feel like I can't really further my science and network nearly as well as I can in smaller symposiums and workshops.
Well, I'm glad you guys brought that up because, yeah, it's a huge meeting. I like that it's a huge meeting just because it feels important when you're there. Like, it feels like stuff is happening and names are, the names that you hear in the halls are like actual big names and like, governors come by.
You can tell by how many pastel colors they have attached to their name tag.
Yeah, the little banners and the name tags. And so one of the things I always get nervous about is, have I represented the diversity of topics at the meeting with the shows that we produce? So that's one of the reasons this year we're producing more shows than ever centered around AGU. And then at the end of the day, I'm kind of just like, you know what? It's a chance for me to get my friends in a room and promote their research a little bit. And that's actually what our first interview today is all about. So it's myself, Tom, and Rob, who are fellow grad students of mine at Wyoming. Tom is still there, but Rob is now graduated and moved on. And they both do kind of geomorphology, sedimentology stuff. And I got a chance to talk to Tom right after he had finished his official AGU talk. And so it was kind of fun, I think, to go from a very formal presentation with your advisor right there in the audience to just chatting with me on the microphone, not really knowing anything about what they do other than they talked about particles hopping around on dunes. So let's go take a listen. I am being joined by Thomas Ashley, but you go by Tom, right?
Yeah.
And Robert Mahon, and you go by Rob, obviously.
Yes. He goes by Robert Mann.
Robert Mann.
This is true.
And we are all at one point in our lives of the University of Wyoming, but Rob, you are now at the University of New Orleans, and you guys have an abstract that was presented as a talk by Tom with your co-authors, Kate Leary, Brandon McElroy, and Suleiman, how do you say the last name?
Suleiman Naqshband. And the title of your paper was Ensemble Distributions of Particle Hop Distance and Travel Time over Equilibrium Dunes. So, first things first, I think this interview will have more talk of hops that's not about beer than anything we've ever done on the podcast before. But something we like to do for people who have somewhat wordy titles is, can you break down your title in like more plain English and kind of tell people just what the title of your abstract and talk is about? Well, first of all, I omitted the ensemble part from the title of the talk that was on the actual talk itself, because I've gone back on what that actually means. But we're talking about probability distributions of the transport distances of particles from when they are moved by the flow. So, a particle sitting on the bed is picked up by the flow because of forces on the particle, and it moves some distance, and then it stops somewhere at some time later. And this is something that people have thought a lot about, but we're talking about this behavior over sand dunes or bed forms is actually what a more general term.
Okay, so a bed form in this instance is a sand dune is a type of bed form?
Yeah, a sand dune is probably a specific bed form, and a bed form in general is like a periodic self-organizing structure made of usually sand when a granular bed is sheared by a fluid.
Okay, but the fluid in this case is air.
Well, it's water or air.
Oh, so you can get water dunes too.
Yeah.
So this particular work focused on dunes on riverbeds and sandy rivers.
Oh, okay. And so can you give us like a working definition of what a dune is for people who are only familiar with the sci-fi novel and don't think about this and...
Yeah, a dune, let's think of dunes as a state of a sandy bed, right? And so when dunes are stable, it's because there's not really a working definition. I guess it's a periodic structure as opposed to a flat bed,
okay,
right? And
got it. Yeah.
So like the idea is you shear a bed with a fluid, and if you have the right combination of like grain size and the gravity of the planet you're on and the viscosity.
You say that because we know there are dunes on other planets.
Right.
Yeah, which is really cool that we know that.
Yeah. And the right combination of, gravity, viscosity of the fluid, the density of the fluid, and the velocity and stresses, applied by the fluid on the bed, then sometimes dunes form. So, and it's like the equilibrium configuration of the bed under those conditions.
And so what kind of geoscientists do you guys identify as? Do you say you're sedimentologists? Or this sounds like sedimentology to me, but...
Maybe like fluvial geomorphologist is kind of that's what I tell people because there was a South Park episode about it.
Oh, okay.
I tell people different things depending on who the people are that
whether you want to continue the conversation with them or whether you want them to not be interested anymore.
If I want to continue the conversation, I'll say sedimentologist or geomorphologist. If maybe not, then I might tell them that I do sediment transport.
Yeah.
And then eyes glaze over sometimes.
Yeah. My general answer to most people is, like, unless they're in my field, is they ask me what I study, and I say, well, sediment transport in rivers.
And so when you mentioned particles, are we just talking about like a particle in this instance is the grain of sand?
Yeah, and it's usually sand because mud and gravel don't really like to make bed forms. They will under like a small range of conditions.
So in mud, the particle size is too small, and in gravel, the particle size is too big?
Yeah. Or like in mud, the particles stick together, and that's a whole nother problem. And then in gravel, it's like usually the size of the bed forms that you would get if there were bed forms are smaller than the size of the gravel, and so it doesn't make them. That's kind of how I think of it anyway. It's like there's a range of conditions where gravel can make bed forms, but actually the stable bed form height has to be bigger than the height of the size of a grain, and like maybe there's like a stable bed form height, but you just get like little sheets of gravel that are a little bit higher than. Maybe they're bed forms, but they're really like hard to identify. They don't really take the form that you see with like really nice sandy bed forms.
And so a dune is just something that forms when sediment of a certain size is subjected to a certain kind of flow from a fluid.
Yeah.
And you guys, your talks always involve a lot of math. So that like there's mathematical equations that are clearly controlling this process you're trying to use to describe this process.
Totally.
Yeah. So we're interested in what the fundamental physics are of the fluid interactions with the sediment grains on the bed that control the motions of those sediment grains such that they can build up these structures of dunes. And so mathematics is like many physical processes, a good way to describe certain physical parameters, physical processes.
Yeah, tends to happen.
Exactly.
There's terminology you guys were using. So there's like anatomy of a dune, right? So can you kind of explain to our listeners who, so they can visualize it, like if they're seeing a dune, what parts are what?
Yeah, so typically a dune is an asymmetric triangular form if you're looking at it from the side.
Yeah.
So it'll have a steep face on the downstream side and a more shallow face on the upstream side. And that shallow face is generally where it's eroding. Particles are being entrained off the back side of this dune, picked up from the bed into the flow.
Put in a train.
Yeah, and those particles are then moved towards the front of that bed form in general, or in front of that dune, and then they will either fall on the front or they will get caught at the very top, or the crest, we call that, and then that crest will avalanche in periodic avalanches.
And that's how the dune moves.
Yeah, that's how the dune will appear to migrate downstream generally.
Because downstream, because in this instance, we're not talking about wind, we're talking about a riverbed.
Yes.
So we have these dunes forming at some point in the river, and then they go down the riverbed.
Yeah, they migrate downstream, and while they migrate, they change shape, and we call that deforming. And I like to think of dunes as 4-dimensional elevation fields, right? So it's like the bed elevation is evolving in time. So there's some there are 3-dimensional elevation fields where there's 2 spatial dimensions, streamwise and cross stream, and then time. And so you can study the characteristics of how that field changes in time, or how the 2-dimensional elevation field changes in time. And you can study that 3-dimensional field and then try to relate that to how the particles are moving over that field. And so that's kind of the thing that we're interested in. Yeah.
And you guys study this. I mean, we mentioned the equations and the mathematical modeling, but the way you build out these equations is by doing experiments with these stream tables that you guys build. So can you guys kind of explain what these experimental contraptions that you put together for making dunes in the lab?
The problem with studying dunes is that the physics are really complex and we don't really understand them. So we do a lot of experiments to try to sort of come up with simplified approximations for what's happening in various aspects of the system, where we can we come up with some functional description that's like a physics equation, but it's not really, because it's not physics, and it has some tunable parameter, and then we make a bunch of measurements, and then we find out what that parameter should be based on our measurements, and then people apply that instead of real physics, because real physics are really hard when you have flow in 3 dimensions and particles that are acting because of the integral of the force of the fluid on the surface. It's a really messed up problem. So we do experiments to sort of come up with simplified approximations for how the system works.
So when you say a tunable parameter, do you mean the speed of the flow of the water, or what are those parameters?
Yeah, so the classic example that I would think of is when you're trying to predict the amount of sediment transport, right? So the flux is the mass of sediment transported past a point, for example, in a river, right? You have a river that's transporting sediment. You want to know how much sediment is being moved by the river. That's the flux. And you relate that to the shear stress of the fluid on the bed by a relationship that and I say we as in the sediment transport geomorphology community has sort of collectively decided at this point that there's an exponent where the shear stress is related to the flux to the power of 3/2. And that's something that you can observe all the time, and people have made all these arguments. That's kind of that makes sense. But really it's basically an empirical relationship that neglects the complex physics of fluid particle interactions, and it just says flux is equal to stress to the 3/2.
Okay.
And that's something that, that's an example of something that you could do.
And so how does that relate to the videos I see you guys showing, where it's a dark room with brightly lit particles, like a rapidly moving star field? What's happening there?
So in these kind of experimental situations, we're generally trying to isolate very specific parts of this puzzle, and where we can really control the variables of interest. So what he was talking about in terms of coming up with an equation that relates some parameter to some other measurable parameter. When we run these experiments, we're interested in being able to vary systematically which parameter we're interested in, being able to measure things in a very controlled environment. So in this particular case, we were able to control the lighting and the sediment that we used in the experiment in order to track particles at the individual particle scale. So those were the kinds of things that you couldn't do that in the field because the water might have too much mud in it, so you couldn't see the bed, or the scale of the river is too deep, for example. So in this particular case, we're trying to control clarity of the water and then pick one steady discharge condition or river velocity condition, essentially.
So these stream tables are they're this trough that you guys dump a bunch of sediment in, some of which is marked so that it glows under like a blacklight, I guess.
Yeah.
And then you have a way of adding water to the flow.
Yeah, there's a recirculating pump that recirculates sediment and water, so whatever comes out of the end of the flume just gets pumped right back to the top.
So this is
So these stream tables, we call them flumes if we're doing river channels. So they're a long, narrow, straight, basically a rectangle of aluminum and sometimes plexiglass, and so we put sand on the bed.
About how long of a flume are you guys working with?
The one at Wyoming is about 8 meters long.
Okay.
Yeah, I just did some experiments in the Netherlands, and the flume was like a meter wide and 14 meters long. So there's a flume at Soule in St. Anthony Falls that's like a meter deep and 3 meters wide and 100 meters long or something.
That's like the Large Hadron Collider of flumes.
Yeah. They actually divert part of the Mississippi.
Goes across 3 countries.
Yeah, exactly. No, I'm not even joking. They divert part of the Mississippi.
Is that the one up in Minnesota?
Yeah.
Oh, okay, yeah. I've seen that facility. Yeah. And so using these, you can basically make micro rivers that you then can experimentally control such that you can derive the equations that apply to also large scale rivers.
Totally. Yeah. So to get back to your question about what we were measuring there, there's this whole field where we're sort of trying to describe how the mechanics of individual grain motion result in what you see at the macroscopic scale. That was the sort of the topic of that session. It was like scaling the granular physics to the continuum. So you take this process that's really complicated at a fine scale, and you describe all of the variability with probability distributions, and then you can generalize that to allow for prediction of things that are happening at a much larger scale. So, for example, if you want to model the evolution of a sandbar, and you know that the probability distribution of particle hops or something about the probability distribution of particle hops, you can actually ignore the probability distribution of particle hops. You can ignore all that fine scale behavior and derive expressions that are much simpler to describe the evolution of that larger scale, like the sandbar or the river.
Is the sandbar a type of dune?
No, a sandbar is a type of bed form.
It's a larger bed form.
Okay.
Yeah.
And so you were interested, one of the things I took away from your talk was you were seeing particle motion that was happening in discrete chunks of time that is typically, it sounded like the way, if I understood it correctly, it sounded like we typically describe particle motion over a longer scale, and you were seeing that when you break it down into smaller scales, there's different types of behavior that you see, like these small little hops leading to one large leap, as opposed to looking at a one large...
Well, actually, I think that's close.
Correct me if I got that wrong.
No, that's close. Actually... So people have considered particle hops, right? And particle hops seem to be sort of the fundamental unit of motion, right? Like a particle is resting on the bed, and then it moves, and then it comes to rest, and that's like one motion.
Saltatory,
right? But
I only know that from nerves. I don't know that from geology. That's also how nerve signals transmit.
That's what we call
saltation. Yeah. And what I realized was that when they're bed forms, actually particles make several of these saltations. And then, like as the bed forms evolve, the topography is going up and down, and some particles are becoming part of the topography, and other particles are going from being topography to now being on the sort of active layer on the surface of the bed form. And there's a scale of motion that is important that represents sort of how far particles travel between the time that they're part of topography till the time that they're part of topography later, I guess, if that makes sense. And it can be multiple hops.
Okay.
Yeah.
And so, like, is that more or less what you found and were trying to describe mathematically in your talk, or was there a bigger picture to your talk that I didn't quite pick up on?
Yeah, so there's a hypothesis, or I wouldn't say it's a hypothesis. It's like kind of something everyone thinks is true and sort of knows, but no one's ever really figured out how to describe the processes in enough detail
like a PhD
to address it. But yeah, there's this idea that basically the transport distances of particles are connected to the lengths of the bed forms. So how far a particle moves is related to the lengths of the bed forms, right? And that's something that kind of everyone knows.
So different sized dunes would have different distance of particle hops?
Exactly. Okay. Well, so that's the thing. It's like we don't.
That's what everyone assumes,
right? We're just like hops. Like, well, I don't know. It's like how far particles move, and like what I tried to do is really clarify. I guess what we tried to do is really clarify the fact that like there are hops, and then there is this scale of motion that's related to dune evolution, and it can consist of multiple hops. So there's models for the physics of a saltation, and the point really is that like the physics of a saltation don't really apply because multiple of them can be linked together at the scale of dune evolution.
That makes sense. This notion that we have in our community that attempts to relate these individual hops or saltation lengths to the length of a dune originate from the windblown ripple and dune community. So where observations existed of dunes under air instead of water that was shearing the sediment and causing the sediment to move. In those cases, what turns out to be a very different type of bed form, a much smaller, what we call ripples in our community, are in that case related to the single hop distances. And so that has sort of pervaded into the literature and into the mind of just general sedimentologists.
So what you guys are finding is that there's something fundamentally different about wind-based dunes versus water-based dunes.
Or there are ripples in water as well, right. But there's something fundamentally different about, I don't know if I want to go here.
You don't have to. I didn't want you to overextend what your results were trying to say. I wasn't trying to push you in that direction.
No, it might mean that there's something fundamentally different between like ripples that are set by the scale of saltations and bed forms or dunes that are set where the particle transport distances between the time spent inside the topography consists of multiple saltations. That actually might be a thing.
Yeah. If you find out that's a thing, come back and tell us more about it.
I'll be like, we'll cite you.
There you go.
You came up with the idea.
Yeah. We acknowledge Ryan Haupt's interviewing techniques.
Yeah.
Are there places people can go see like riverine dunes?
Absolutely. Most people probably live within a few hours of a sandy river, and many of these sandy rivers are shallow enough that, or even have portions of the river that you can access and walk along. And anywhere, if you're standing in a eddy or something like that, it may be shallow enough that you can walk out there and you can see these dunes. Oftentimes, if there's a flood in town and there's any sandy sediment floating on or sitting in the street, it might get funneled into your gutter, and you might see dunes the next day that got dried out. I used to see those all the time in Laramie. I see them all the time in New Orleans now.
I bet.
So they're quite ubiquitous. Really common.
So it's one of those things. Once people start looking for them, they'll probably start finding them.
Yeah,
absolutely.
For sure.
Do they affect the flow of the river, or do they have an effect on the river's? I want to say life history traits, but like the way the river moves and changes its flow over time.
Yeah, totally. That's sort of one of the big reasons we care about them is the fact that when they're stable, they make the bed of the river more rough. So by making the river more rough, if you think of like roughness on the bed as like resistance to flow, then when you supply a discharge or when a discharge is supplied.
This is getting very close to everything in geology as a sexual innuendo.
Yeah.
Talking about rough bedding and discharges.
Yeah, supplying a discharge. Yeah. So when you supply a discharge, the depth of the flow is controlled by how rough the bed is, basically. So the discharge is partitioned into velocity and depth. And so if there's dunes on the bed of the river, the flow is going to be deeper for a given discharge supplied from upstream. So that's something they actually care a lot about in the Netherlands because they have these levees that are protecting all of the people from the rivers that are higher than the places people live. And so they want to know how much water they can let out of a dam before the levee floods, and they have to predict what dunes are going to do as a part of
And a great way to predict things is to have an equation that works.
Exactly.
And to figure out how the equation works best, you have to do these flume experiments.
Yep.
That's really cool.
Yeah.
And we hear so much about, especially now that you're in New Orleans, like we hear about river discharge having big downstream effects, but like downstream in both the literal and the ecological sense in terms of like the floral and faunal communities of the Gulf of Mexico with all the fertilizers we use and everything. So I imagine understanding flow rate for these big river systems is going to make a big difference in how we understand that.
Totally. That's definitely true.
Yeah. And on top of that, I'd say one of the motivators for this project initially, and for some of the work that we were doing, looking at not just the scales of downstream transport, but the scales of cross-stream transport. So when what the influence of roughness on the bed, like dunes, how that results in particles not just moving in the downstream direction with the flow, but moving across the river, how that motion of sediment across the stream balances the motion of sediment off the banks towards the center of the stream to help understand better the processes involved in setting up the width of a river, for example, and the width relative to the depth of that river. And if dunes play a part in partitioning sediment towards the banks more so than would be predicted from just looking at, say, a flat bed, which doesn't send particles as rapidly to the banks.
So for a river to have dunes, it has to be like silty or sandy, I guess. So if you have just like a rocky river, like I would think where I would try to go trout fishing, you're not as likely to see these dunes. This might be completely off the rails, but like I'm fascinated by the ideas of what rivers were like before there were plants. Right? Like,
this is definitely a discussion.
A hot topic.
Yeah.
Oh, is it really?
What were rivers like before there were plants?
Wouldn't they have just been like giant braided streams? I don't.
I think that's a pretty pervasive notion in the community as well, and there are a lot of reasons that we think that many people think that.
So this is stuff you guys think about. I'm not totally off base.
Yeah, this is totally
on a daily and hourly basis.
Okay, cool.
Yeah,
absolutely.
Yeah,
I think it's so cool that like much like life on Earth, the water that supplies everything that life needs to live also is evolving in tandem with us, and the way that the water moves around the landscape is this interactive process between life and geology. And I think that's just, I don't know, I think it's kind of poetic and kind of cool.
Totally. Yeah, absolutely. And in the case of rivers specifically, you mentioned braiding and meandering rivers, right? So there's a lot of discussion in our community that's relatively recent about whether plants on land, on the banks in the floodplains, they have the ability to trap sediment when the bank or when the river goes into flood stage and flows over the banks. And so they can trap sediment, which is generally finer grained, which means that the banks will be more cohesive because they're made more out of clays, whether that influences how stable they are and how the river can change its width versus its depth, and how that changes its plan form, what we call it, the presence of bars in the middle of the dune, of the river, and so forth.
There are two types of rivers. There's not really. There's
two end members.
There's two end members. There's meandering and braided rivers, and there are some people that will tell you that before vascular plants existed, there was no such thing as a meandering river.
I've heard that. I've been told that and I'm a paleo.
I don't believe it, but that's just that's my bias. Okay. I spent a lot of time looking at very old rocks where I've seen what I believe are sedimentological.
We need to find a meandering river on Mars, and then
there are meandering river deposits on Mars.
Unless there are not plants on Mars.
There have been arguments made for
vascular plants on Mars.
No, for the fact that potentially the bank material that was stable to allow those rivers to meander might have been frozen water in the pore spaces, so that could have caused that cohesion.
See, all you need is something to cement the sediment together. It doesn't have to be. So when we say vascular plants, we're talking about terrestrial plants that have a root structure that's going to hold the soil together and
and trap fine muds and so forth.
And also break up larger rocks into sediment in the first place. Like a lot of small, fine scale sediment exists in part because plants are there to break it up and make it happen.
But just as an extreme case of this, there are meandering rivers that you can see on the tops of ice sheets that are where the bed is made out of ice, and
that's a perfect
the sediment, if you will, which are ice crystals, float on top, and they're eroding and meandering because of the kinetics of the fluid causing heat generation on the outer banks and so forth. So
that's really cool.
So it doesn't necessarily require plants specifically, but other forms of cohesion can also result in that.
Well, I have two more questions for you guys. First question is what's coming next for both of you? Like, what are your kind of or you know, you don't have to answer if it's like super secret, top secret science stuff, but just in terms of like where, you know, now that you've presented this data and this idea here at this conference, obviously a larger publication will come out of this, but like, what are the future kind of projects that you're thinking about, or what are the future questions you're hoping to answer with the work that you're doing?
Well, I guess short term, I measured a really tiny area in the experiments that I presented today. And I just did some experiments where I measured a much larger area, and so I can address the problem of these aggregate steps that I was talking about. And basically, I'm scaling up this research, and one day I'd like to finish my PhD.
Well, wouldn't we all? That's an excellent short-term future goal. It might end up not being as short-term as one would hope.
No, don't jinx it.
It just takes motivation.
Yeah. That's
sometimes in short supply.
I understand that. For me, I just started a faculty position at the University of New Orleans, so I'm working on building lab facilities. So I'm building instrumentation for a flume at a fairly large scale, as well as trying to start up some field projects on some deltas down in Louisiana, and looking at flow and sediment interaction in vegetation, apropos to what we were talking about just a few seconds ago. Yeah. And so my biggest future plan is to try and recruit new graduate students to come help me work on some of those projects.
We do legitimately have a lot of high school and undergrad listeners. So,
fantastic.
My next question, and then I do have one final question, is how can people follow along with your research? Do you have I know you're on Twitter. Are you on Twitter?
No. I'm technically on Twitter, but I got on Twitter and then I never looked at it again.
Sure. But where can people find you guys online or follow along with your research if they want to get updates on stuff as it moves forward, or apply to work with you? Yeah,
so I'm pretty easy to find on the Twitters and elsewhere. So you can find my Twitter is, I believe, at Robert C. Mahon.
I'll link to that in the show notes.
And then I have a website for my lab group, which is www.bedform.org, which shockingly wasn't already taken.
That's pretty great, yeah.
Wow, that's exciting. Yeah, that's a good URL.
Yeah.
And Tom, you have a website because I thought I was only interviewing you, so I went and I printed out your resume just so I would have it. You do have a website. I imagine it's the one you had to make as part of the fundamentals of research class.
Yeah, don't give anyone that URL.
So that one might still exist for me even.
I know mine still exists, but mine exists, and I had them port before Brendan left. I had him port my actual URL on top of my University of Wyoming URL. But if you're on a slow browser, my old Wyoming page that I built would load, and then my new page takes it over. So if you can stop that right before my new page loads, you can probably still access my old page. Which is kind of a cool little internet artifact.
I'm looking up what my Twitter is.
Okay. Well, while you look that up, my final question for you guys is, if you had the opportunity to study dunes on any other planet besides Earth, which planet would you pick?
Probably Titan.
I figured you guys. I was guessing. Yeah. If I had to guess, I thought you were going to say Titan.
Yeah, Mars is boring. Mars is
Mars is not boring. There's a lot of.
But is that a fluid bias? Is it just because you want a liquid fluid creating your dunes?
That's definitely part of it. Yeah.
Yeah, I mean, methane dunes.
Transporting ice crystals?
Transporting methane ice crystals. What more could you want?
I bet it smells terrible, though.
I love that smell.
You love the smell of methane?
Yeah, sure.
He smells his own farts. I still don't have my...
I think all professors do. Isn't that a requirement?
Well, I think while Tom looks this up, a question I'll ask you, since you talked about recruiting students. If a person is in a geology program right now for their undergrad, what are the kind of courses that they should be looking at taking to be prepared to come work in a lab like yours?
Yeah, the standard geology curriculum. I still strongly value field experiences, field courses. Maths and physics, I can't stress enough, because
Did you say maths?
Maths, yes, as
very
the Brits,
British.
As the Brits would. As an undergraduate, I wasn't as well prepared in math and physics as I would like to have been, and I think I when your advisors tell you to do well in calculus and physics, trust them. It's useful.
Yeah,
and it makes the world a lot more interesting and tractable.
Also,
natural world around you.
statistics. Did you say statistics already?
He said maths, which implies that multiple types of maths, because there's the calculus math and then the applied math of statistics.
Yeah, but no. Well, there's
Or
calculus,
like probability theory more than statistics. Yeah. Anyway.
I mean, definitely statistics are good.
I think we can all agree on that here. If there's one thing science sort of stands for, it's that statistics are good.
Bayesian statistics.
Ooh. I mean, I would
I'm
agree
not
with
getting
that. I'm
into
just
that.
not as good. You did just say probability. Well, or we don't have time. We're out of time for dealing. You can come back on and promote the works of the good Reverend Bays at a later date.
I have my Twitter. It's Thomas C. Ashley with an @ symbol before it.
That's how Twitter works.
Okay.
Yeah, you'll learn once you start using it.
Yeah, I'll figure it out.
All right. Well, if people are listening to this, go at him in a tweet so his phone starts pinging him and he wonders why everyone is suddenly sending tweets. And with that, thank you both for joining me and telling me a little bit about your work. This was fascinating.
Thank you.
Thank you.
All right, so that was my chat with Tom and Rob. Fun to catch up with them, and was very excited when I mentioned the idea of dunes on other planets, that they were super into that. I would have been really disappointed if they were only terrestrial-based dunes, right, Charlie?
No, definitely. I'm trying to remember this book I had read a long time ago in grad school that I loved. I think it was by
Dune by Frank Herbert?
No, it was like Bag Gold or something like that. It was called like The Physics of Blown Sand and Desert Dunes. It's this amazing book. The guy wrote the like seminal book on aeolian physics, and he wrote it out of boredom during World War II, during the African campaign. So he's this English guy that was in Saharan Africa and just started taking notes on everything.
That's kind of crazy.
Yeah,
it's totally crazy.
For that, they just, if when in doubt, they just start writing stuff down that they see.
Yeah, shoot at Nazis every once in a while and then do some dune physics.
Dunes are kind of crazy because they're not the kind of thing, like if you had ever just asked me if you take all the sand in the world and blow it around with some wind, what happens? And I would say you'd have some varying sized piles of sands. I would never predict that a dune would form. It's kind of a cool emergent property.
And yeah, what are those Barkin dunes that actually...
The singing sand dunes?
No, Barkin dunes. They're this like crazy chevron shape, and they or crescent shape, and they self-replicate. They're a true dissociative structure. They consume a wind energy gradient and create a structure of lower entropy that is self-replicating.
Wow, so there's like dune DNA, or not DNA, but there's like an element of life.
Yeah, living dunes basically, and they're surrounding the North Pole of Mars and in the larger deserts in America, including Death Valley and the Sahara.
Yeah, I feel like if there's something that happens on Mars, if you're going to have it happen on Earth, it's probably going to be in a Death Valley type place. Dry and extreme.
Hey, this theme's really starting to come together.
Dry and extreme makes you thirsty? How's it coming together for you? What did I say?
Here we are with, see, you knew before the episode started, because you did the interviews, what we were talking about. But for Charlie and I, we just had to sort of take the theme as it came, and now the pieces are starting to fall. And it's just like the listener would be experiencing. There's, the theme and the stories start to congeal and make sense.
Well, let's see how much sense they make after we've had a drink, which we will be doing in our next segment.
Red blood and then we'll all go into the river below. Running from the inferno. They'll think I'm insane, but y'all all know my name. Into the river below. Running from the inferno. I'll take all the blame. The front page and the fame. I'll take all the blame. The front page and the fame. Right to the river below. Right to the river below. Right to the river below. Right to the river below.
It would not be an episode of Science, sort of, and particularly not an episode from AGU, because AGU as a conference is somewhat renowned in the geosciences for, it's reached a point where it's not even that they make free beer available, it's that they start like forcing beer on you at around, it felt like it got earlier and earlier every day. It was like 3:30 maybe when they still had coffee out and the beers just started flowing, and it was this year, like they were so on top of getting the beers out that there would just be tables with cups just up for grabs that you just walked up to and took a cup. There was no line.
That is an improvement. Yeah.
Yeah. So with that in mind, Patrick, did you have to wait in line for whatever you're drinking now?
Well, no. Fortunately, my house doesn't have a line in front of the bar. But what do I have? I have a port wine.
Ooh.
Yeah, so port wine is something I used to enjoy, I feel like about 15 or 20 years ago, a lot more than I have lately. But I'm in Europe now, and I figured I was close to some...
You're in Europe, and when you say now, you literally mean for right now, because apparently where you're sitting is about to not be Europe as soon as they can figure out their Brexiting.
Yeah, I guess organizationally, it won't be Europe anymore. I'm not sure changing the location is going to be quite as easy. But yeah, so port wine was something I used to drink a lot. Thought I'd give it a shot here when I probably haven't had it in a while. And so this is not, I don't think this is an especially good one, but I bought it and now I'm drinking it. Dow's Trademark Finest Reserve Port, obviously from Portugal. And I can read you about it. Apparently the Symington family owns this one. And 6 members of the family still manage much of the winemaking and the blending. And I will go ahead and take a sip here.
Charlie, are you a port guy?
Not really. I prefer like less sugary.
Yeah, that's the thing.
Booze in general.
It's sweeter than I remember from long ago. So I don't know if I just don't know what I'm doing in choosing one, or yeah, they really are that sweet.
Because there's all the different like tawny versus ruby, right?
Yes.
Yeah.
That is a thing. I can't tell you.
Oh, neither can I. Yeah.
Yeah.
I know we use some port when Julie makes her glögg, which is like a traditional Swedish mulled wine, but it's it's a part of a much larger concoction, so it doesn't end up overly sweet. But I've had ports that I really very much enjoy, but it's not the sort of thing I keep around on hand.
Right. Well, I guess I've been noticing them at the end. The after dinner drinks are a bigger thing here, and so I started seeing them listed a lot, and I was like, I should buy some port wine.
They last a long time, right?
That's the whole point.
Not like a normal bottle. Yeah.
Right.
Yeah, my dad's into them. He'll always like pour me a little glass after I have dinner over at his house, but
because they're fortified with more alcohol.
Right.
So they can
like
survive.
Mad Dog 2020.
Exactly. Well, yeah, because they were originally made for like sailing vessels that were going to be out at sea for a long time, and the wine needed to stay good and not go bad. So it's one of those. Like it's like the IPA of wines.
I guess so.
Yep, I'm calling it now. IPA of wines. Ryan Haupt, 2019.
Yo, bro, you serving any hazy ports?
Higher alcohol content, I guess.
One of those East Coast hazy ports. What about you, Charlie? What are you having?
Nothing. Nothing exciting. It's 1 p.m. I'm in my office, and so I just opened up a drawer to my desk, and I had choice of
wild turkey or
yeah, I got that same Uochi cold brew matcha green tea that I had last time, or I had a few cans of La Croix. So that's what I'm gonna crack open. A Tangerine La Croix for you uncouth Americans.
The Wisconsin-based beverage La Croix.
Mm-hmm.
It's like if water remembered that citrus existed.
Yeah, tastes like a tangerine, I guess.
If that's what you're looking for in your life.
Without any sweetness. It's hydrating. There's not really much to say.
On LaCroix.
Yeah. Apparently it's been a huge service to people trying to reduce alcohol consumption or quit alcohol, because it's like a thing to crack open and hold at night.
Yeah, I can totally see that. I definitely have friends that are super about the LaCroix and can talk impassionately about the flavors they prefer. I think it's fine.
Pamplemousse is the best one.
I'll have one if it's the option available, but it has yet to become something that I seek out. I haven't bought in that hard yet.
Mm-mm.
But instead, I am having a Braven Brewing Company Skrrt IPA double IPA, which is Braven is a brewery out of Bushwick, Brooklyn, New York. And I got the beer because it has a antlered chimera on the label.
Oh,
so I was like, that's perfect for us. So if you guys look, I'll drop an image in the Slack and you can see it. But I believe it is a raven with buck's antlers. I think that's why it's Braven. And so, I didn't have like a strong desire to get this beer for any other reason.
It's a raven with brachiolope antlers. That's why it's a Braven.
Yeah, I think so. Convergently evolved, clearly, since they're both dinosaurs.
Right.
But yeah, it's very, very good, clean drinking double IPA. Nothing too crazy or different about it, other than it being well made and enjoyable. But I just really liked the label, and I couldn't resist something that was so reminiscent of the Brachiolope.
Yeah, good call.
Yeah, have you seen High West's Boo Rye whiskey? That's another antlered beverage.
Save it for the show, I guess. Why are you telling us about it now, Charlie? Go get a bottle and then feature it at a future recording.
Because at work at 1 p.m. I can only talk about it. That's why.
Maybe towards the end of the term.
Yeah, when grades are due.
I do know professors that have whiskey in their desk.
Yeah,
I'm just not that brave yet.
Yeah, it feels like a very old school choice.
Maybe get tenure.
Yeah.
Well, Charlie, I feel like I should have made you go last in the rotation because my next interview is with Mike O'Connor, whose research works on thawing permafrost and ice and the release of CO2. And you're having I guess we're both technically having beverages that release CO2, but yours is just waterier.
Yeah.
Anyway, we're gonna talk to Mike.
Is that relevant?
I don't know. just reaching for any transition at all. Let's go talk to Mike.
Lay it on us, Mike.
Summer's day, I only find it slips away to gray. The hours they bring me pain. Tangerine, living reflections from a dream. I was her love, she was my queen, and now 1,000 years between.
So I'm being joined by Mike O'Connor, who is a doctoral candidate at the University of Texas at Austin. And according to your website, I'll just read right off it. You study hydrological phenomenon in the real world and model them numerically to better understand our societal and global problems. And I love the first line of your dissertation in 1 minute. And I might steal my dissertation in 1 minute thing from my website. But diffusing the Arctic carbon bomb. So let's talk about your research maybe broadly a little bit, and then we can talk specifically about what you were presenting here at AGU. Does that sound good?
Absolutely. Sure.
Okay, so what kind of scientist do you identify as when people ask you?
That answer changes depending on who's asking.
I get that a lot.
Yeah.
People bob and weave with whatever the situation is when explaining what it is they do.
Yeah,
so.
I mean, I absolutely operate on the nexus of a number of different disciplines. I'm trained as a hydrologist. I study water flow. That's my job. But the general public doesn't really understand hydrology as a field. So I usually either say I'm an earth scientist or a climate scientist because what I do impacts both. Also, saying you're a climate scientist in like a crowded room of muggles actually raises some eyebrows.
Okay, we're calling them muggles now. Okay, good to know. So you see the University of Texas as Hogwarts, I guess, in this scenario.
Maybe it's more the what's the one in Germany, the bigger.
I can't remember the one. Yeah, the ones that have like the staffs instead of wands.
Mm-hmm, mm-hmm. No, it's a wonderful, huge place. Yeah, it's no Hogwarts. We know like 10 people in our department. There's 50,000 people there.
So how does being a hydrologist put you in a realm where you can speak about what's happening with Arctic carbon?
Okay, awesome question. Yeah, there is an enormous amount of carbon in soil. Twice as much carbon as in the atmosphere is in soil.
Okay.
And half of that's in Arctic permafrost.
Oh, really?
Half of it.
Okay, so we're not talking about like Arctic ice. We're talking about land.
Soil.
In the Arctic.
We're talking about soil in the Arctic. And specifically soil that has been frozen for a while. Turns out we've turned up the temperature in the whole system, And that means that some frozen soil, previously frozen soil, is now thawing.
So becoming water.
It's becoming a slurry of water and dead organic material, and that is really good food for microbes. And then those microbes, microbially fart and release carbon dioxide and methane.
I mean, it sounds almost like what literally would happen if you just opened your freezer and just left it open. And things would thaw and then start to rot, and it's going to get real gross real fast.
Absolutely, and that's what we're looking at really, it's an enormous stock of carbon. It's as much carbon as is in the atmosphere.
Wow. Okay.
Right now.
And right now it's trapped, but
yes.
It might not be trapped.
It might, and we're not sure. So the reason we're not sure, like it should be a relatively simple question, but the problem is that water controls the whole dynamics of the system. If it's damp, cold, wet, saturated, really, that means there's very little oxygen. The microbes will make methane. Methane is a really, really potent greenhouse gas, 25 times more potent than CO2. If it's drier, if it's warmer, if it's more well-drained, then you make CO2, which is less potent but lasts longer. And now you overlay on that whole problem that when it's cold, microbes work less than when it's hot. So you have arguably more production of a less potent gas versus less production of a more potent gas, depending on what the water condition is, and nobody knows how much water is going to be there. So
interesting, because we don't know once the ice melts, is it going to drain or not?
Exactly.
Wow.
That's why we need to start at the very beginning with the water cycle.
Okay, and so what kind of data do you collect? Do you go out in the field, or how?
I actually collect about the simplest data that you can possibly collect. I get water levels from soils that are really shallow, like 3 feet down. You stick a tube in the ground and you literally measure the height of the water in the tube.
This is up in the Arctic?
This is up in Alaska. Yeah, we do that across wide areas. We measure the depth to the permafrost, the ice depth.
You just stick until you can't stick in the stick
That's
anymore?
That's exactly right. That's the very scientific process. We call it we brought a field assistant from Hong Kong out there and she called it just her weapon. But yeah, it's a thaw probe. And then the last thing you need to understand are the properties of the soil. So how well do they transmit water? How much carbon is in the soil that you're looking at? And how well do they transmit heat? And so if you're thinking about this at all from a math perspective, if you're listening as a scientist, I just outlined Darcy's law.
I've never heard of that.
It's the rule for all groundwater. The amount of flow you have is the product of how steep the hill is, right? Water goes downhill.
Yes.
So the amount of flow you have
I agree with.
You got to have a steep hill for flow. You have to have a thick aquifer, right? A thick amount of flow, so big area. And you also need to have a soil that is permeable. So the product of those three things gives you flow. And so we go out and measure those three things.
That's really cool.
That's it.
That seems incredibly elegant, but probably hard to scale up to a continental.
Well, the next, and then, so
mass.
that's when it gets a little bit more complicated. That's where we actually have a fair amount of NASA money to try and ground truth what we got in our small locations to satellites that look at things like soil moisture and look at ground deformation, right? When ice freezes, it expands 10%.
Mm-hmm.
So you can see the ground shift.
We don't talk often enough about how weird it is that ice gets bigger when it freezes.
Yeah,
nothing else does that.
There's a little bit of weirdness to that.
Yeah.
Water's super weird.
Yeah,
actually.
But it's responsible for a lot of like how Earth works.
We're alive because ice freezes from the top, not the bottom.
Right. So weird.
Yeah.
And so was that what you were presenting at AGU? Should we shift into talking about your abstract a little bit? Let me read the title of your abstract.
Oh boy.
We play a game here on the podcast where I read the title and then you have to say it back to me in plain English.
Help.
So your title is, and one thing we've noticed that is a problem with this game is that a lot of times what you write as the title of your abstract might not be what you end up actually presenting on. So you're allowed to defer to that as a defense.
All right, cool.
All right, so you presented a poster yesterday called Predictability of Variable Arctic Soil, Hydraulic and Thermal Properties and Implications of Such Variability on Future Thaw.
Yes.
So that to me does seem like what we've just been talking about.
A little bit, yeah. Basically, do the plants and the slopes that you see on the surface predict what the soil looks like beneath your feet?
Okay, so this is the first time plants have been brought up. So how do plants factor into the work you've been doing?
Plants, I mean, only in that they're an indicator.
Okay.
They're an indicator of the subsurface. Okay. So we don't have any trees As far north as we are, there are no trees at all.
Are you in the Arctic Circle?
We're north of the Arctic Circle. We're north of the Brooks Range in northern Alaska. We're actually not too far away from we're in Anwar, where they're about to drill a bunch of oil.
I hope not. Is that happening?
It seems like they sure want to.
Ugh. So I guess, so it's worth mentioning that, like, much like when you go up a mountain, there's eventually a tree line that works latitudinally on Earth too, right?
Yep,
so once you get above a certain latitude, trees just can't really hang anymore.
Mm-hmm.
Okay, so you're above that
We're
point.
above that, and the reason the trees can't grow is because the soil is frozen, so the roots die. They can't get those roots in deep enough to survive. But there are shrubs. There are lots of woody shrubs, and so you can see where there are shrubs, you have a different type of soil than where there are grasses. Where there are grasses, you have a different type of soil than where you have something called tussocks, which are a real weird plant that it looks like Dr. Seuss has made. They look like, the Lorax, just little tufts of stuff. But anyways, I am not a botanist, an ecologist of any sort. All I use the plants for is as a clue for what's the soil like underneath them.
And do you collaborate with plant people or like what?
Yeah, there's a couple of botanists at Columbia that are really good at identifying like super like species specific what plant I'm looking at is, and basically we've been working together and to figure out like, okay, how much detail is the least amount of detail that we need, right?
Right. And so you take all these measurements, and then it sounds like you're creating a model. Which is where the math comes in.
Yes.
And then you're trying to test that scaled up model against a much bigger space. And is that what you were presenting on with your poster?
This was not a scale up poster.
Okay.
We didn't get to the stage of building the scale up. What we did more so was test the impact of we found like 3 unique types of soils and 3 unique types of columns, right?
Oh, okay.
Like these 3 types, there's either a thick organic layer, a thin organic layer, or a thick but impermeable organic layer.
Interesting. Okay.
Those are basically across the 200 sites. That's what we found. We broke them down, which is a nice simplification of it. And I fed them into the model to basically ask the question, do we care? Does this variability affect hydrology?
And is that effect you're looking for the difference between methane production and CO2 production?
No, it's just the effect of is it drained or not. So indirectly,
okay.
Yes. Is it drained? Is it cold? Is it wet or dry?
So the drained is the direct effect, and then the whether or not it's methane or CO2 is the indirect.
Then there's a biogeochemical model that goes into that does all that
so it
stuff.
does get more complicated.
It sure does.
Why is it always getting more? Modeling, we're trying to simplify it, and then as soon as you simplify it, you realize like, oh, this doesn't cover nearly as much as I needed to cover.
I mean, but that being said, that's why I did this study was to try and figure out, do we need to go to this really complicated level? And it turns out in most cases, yes, we do. But there are only 3 categories that matter, and we can predict where they are.
You have an interesting twist on all this in that you also have some policy experience, and you talk about your outreach in 1 minute on your website as well.
Yeah.
And you say that you connect water science and water policy. And I really liked how you write this. I'm going to steal some stuff from your website.
Go for it.
And you said water is life, and it can lead to some pretty ugly legislative fights, which is incredibly true, especially, I mean...
in the West in particular, but yes, absolutely.
States are always suing each other over water rights because rivers don't care. They're just going to
Right.
flow. And if one state dams a river upstream from another state or dumps a bunch of pollution that flows from Tennessee to Georgia, like that's a fight.
Yep. Mm-hmm.
So yeah, can you tell us a little bit about how the research you do, but also just your general role as a hydrologist has affected your ability to talk to policymakers?
I'd be lying if I told you that my Arctic hydrology work is critically important for water resources. It's critically important for global climate, but it's not a water resources issue, and that's really what got me into the field in the first place.
You've got Arctic carbon bomb on one side of your research life, where you're trying to figure out how bad it's going to be when the Arctic thaws, and then in the meantime,
and just in general, I mean, you take a dissertation project that's available to you at the school, and this was one that was really compelling to me. But in the meanwhile, you have to recognize where your funding comes from. Your funding comes from the government, and the government needs to have a voice of science in it. Otherwise, you can sit in a staffer's office and they're just going to sort of brush it off. And we need to defend our livelihoods in those buildings. And we also can show through that defense how useful we are. Right. So my background is mostly Texas water policy and Western water policy. Those are the things that we've worked on. And
Western is defined as just
west of the Mississippi. Yeah.
The big water.
The arid. Exactly. The arid states that really have
We've talked on the show before about how just like ridiculous the country is when it comes to being divided by this giant river that kind of doesn't make sense as a water drainage basin.
And it's 200 feet deep. I mean, it's like an ocean. I mean, it's absurd. But most of what I've worked on is simply not specific bills, but translations of hydrologic terms and hydrologic science to the policy of things like in Texas, there's a lot of push for new water storage strategies. One thing is called aquifer storage and recovery, basic ASR. Basically, you shove excess water into a rock and wait until you need it, and then you pull it back. Right. And that's better than a lake in many cases, because a lake, you have a lot of evaporative loss, especially in a state where it gets to 110 in the summer. You probably don't want to have the water sitting out, and you lose feet per year.
Yeah, big surface area. Yeah. And so you're not just volunteering to help out policymakers out of the goodness of your heart. You actually worked in policy.
Yeah, absolutely.
So what was your role when you were working in policy?
I was as a legislative intern in both cases for committees.
Okay.
And so a committee would have a bill come across, whether it was like some sort of reauthorization of dams or appropriation of small streams, or a redefinition of waterways or something like that, as we just saw happen. Many cases, because of the power structure when I was working in these bodies, I was working on the side of the bill that was trying to kill it rather than trying to see it forward, because there was a lot of expansion into the private sector into public sector work. But yeah, it's generally, what science do we need to show that this policy either is good or bad?
Oh, okay.
Right?
Yeah, gotcha.
And who needs to, what stats can we put out on the floor? What stats can we put out to media? What stats can we put out to our Facebook followers, which that is a huge part of government now?
Really?
If you're going to have a bill that you want either through or not through, you can reach out and, call the offices. Here's the numbers. These are the people that we need to flood the phones of. If you're in that office and your phone's ringing off the hook, it matters.
And we've seen that sort of phone ringing off the hook thing happen where everybody on Twitter is call your senator, call your legislator for more social policy.
Absolutely.
But I think there's significant downtime between those events where maybe you could make a call about some science policy too.
Absolutely. I will say that the calls, from what I've seen, it works best in bursts. They're best done when organized.
Okay.
Right? Because what you want to do is you want to kind of piss off the staffers. If they can't answer their phones, then they think that there's a real problem.
Interesting.
Yeah. One of the good local examples of this is in Texas. We had a situation where basically groundwater is a private property right in all of Texas. If you buy the land, you own the groundwater underneath your feet, which is a problem because it flows. Right? So if you put a pump in your property, you're stealing your neighbor's groundwater, but legally you're not.
Right.
So you end up with these arms races of who can put bigger pumps on their land to grab out more water, and then you just deplete the heck out of the aquifer.
Sounds really self-defeating.
It's super stupid.
That's a really interesting story, and does, I think, illustrate how complicated these issues can be to handle legislatively and scientifically. But I want to ask about, what was the reception to you pushing a more scientific agenda or pushing the scientific data when you were working in policy? Were they receptive to that, or do they just want the data if it supported what they were already wanting to do?
So in the Texas Ledge, I worked in the Texas Ledge and the U.S. House. In the Texas Ledge, I was really just tasked more as an information translator.
Okay.
So I wasn't pushing a policy agenda, and because of that, they were happy to hear what I had to say.
Okay.
In that, there were some hints thrown in there of as I just said with the groundwater law, I would put in the policy memo that mathematics will show you that the rule of capture is stealing.
Okay.
And that's just that's not an opinion. That's a scientific fact, but not necessarily too much of an agenda there. When working in the U.S. House, there was a clear agenda, right? That office was a Democratic office. That office was tasked with pushing Democratic bills forward and stopping Republican bills.
Did you feel hamstrung by that, or did it generally jive with the data you were trying to get out there anyway?
I mean, mostly what we were doing was in line with, I think, best practice science. That's just sort of how the parties align right now. But there were some cases where I thought we were fighting battles that were unnecessary. Water isn't partisan inherently. I mean, if you have a drought, everyone is upset.
Well, and I've heard we talk about, war for oil and war on drugs, but I remember hearing at one point that more wars have been fought over water than any other resource.
Apparently, the Arab Spring was sparked by a water shortage, as was the Syrian civil war.
Because you can last a lot longer without oil than you can with water.
Yeah. Oh, absolutely. Yeah. I can't speak more to those ideas. Those are things I've heard.
Yeah, no, but it's like, I think my intention was just to emphasize.
Oh yeah, it's super important.
Your point that water is life. Like that's,
And yeah, the issues that we worked on the Dem committee often were intentionally antagonistic. And there were some cases where we could have crafted water legislation, at least, that would have seen movement on the other side and didn't pursue it. And I'm not sure if that strategy is part of just the broader democratic platform or what, but that was my experience. Most of the time I was fighting for bills that I really did believe in. Sometimes I was surprised I was fighting for a bill that I'm sure I did believe in, but seemed lower priority than one we could actually.
So by and large, it was a positive experience for you?
Yeah, absolutely. Absolutely.
And up there with doing research, like, are they complementary to you, or is
no, not at all.
which is your baby? Which is what you?
Oh, I'm not sure. I thought up there with. I don't know.
I just meant like, yeah, they, yeah.
Yeah, no. The research I do does nothing to help the policy work that's gone on. But yes, they're both super important. I do find myself.
Is it tough to switch gears?
Yeah,
it is.
Yeah, I do. I was just about to say I do find myself, if I'm doing one for a while, it takes a very long time to get back into the other.
Well, we had to do a little bit of both this week because this is the first time I think I've ever recorded this podcast in a suit.
Oh,
you are also wearing a suit,
which is the weirdest thing.
I think we both look good, but it's we're not dressed for radio just to do radio. We're dressed up because we both have meetings on the Hill, which is one of those DC phrases I love to get to say because
to the Hill.
It's not as special a place as people want it to be, but it is just a fun little bit of jargon to say. So one thing AGU does during the fall meeting, I think, because the fall meeting is taking place here at Washington, D.C., they've set up a congressional visit day today on Friday at the end of the meeting. And I've participated in a congressional visit day before, but I had like a handler and they kind of walked us through it. Whereas this seems a little bit more of a scattershot approach to let's just get as many scientists up on the Hill as we can. But it sounds like with your background in policy, you probably have some effective strategies for managing these kind of meetings. So
it was interesting because I've been on the other side of the meetings before.
Yeah.
I've been the guy listening rather than the guy talking. And so I did kind of have a little bit of an idea of like, what does a staffer just not care about?
Well, so let's explain a little bit how these meetings work.
Yeah.
So you basically, you or whoever's running your congressional visit day will reach out to the legislative staff, which is, the young people who work in the offices of the old
Very
people
young.
on C-SPAN.
Crazy young.
Yeah, like there's a big bimodal distribution there. And so you get a meeting. Usually it's not going to be with the actual representative,
right,
unless you're coming, like when I was in Wyoming and did a Wyoming one, I was meeting with the actual representative because Wyoming's a small state, not as many people, not as many meetings to deal with. So you go to their office on Capitol Hill. You have 15, 20 minutes, maybe
20 minutes,
to talk about whatever it is you want to talk about. And so you're sitting in a room, you're across the table from these young people who are going to then advise the representative. And I'm saying representative because it's both, congressperson, member, because it could be Senate or House of Representatives. And so from there, let's imagine that you're giving a scientist advice who's sitting at the table across from those people, like what's best tips and practices for having an effective meeting?
They got to know why you're there instantly. Right? You have to have a reason for being there. And sometimes just saying increase science funding isn't good enough.
Okay.
I mean, in a lot of cases, like that's easy. Everyone on their face believes in science. But what you need to walk in and you say is, I'm here because I'm concerned about the trajectory of the budget of the NSF.
Okay.
Or something like that. Or I'm concerned about the trajectory of the budget of NASA. Or I'm concerned about leadership, or there needs to be a specific issue because that staffer likely is able to have a totally fine 20-minute, completely forgettable meeting with you about how important science is for the world. Not that there's anything wrong with that. However, I think it's much more effective if they report back to the member's going to say, what did you do today? And I said, I met with a person from AGU. And what did they say? Well, they just said increase science funding. We're moving on.
Is there value in having these meetings? So the other, because the U.S. has a two-party system right now. If you're meeting with a member of the Republicans, that tends to be the party that wants to cut science funding. If you're meeting with a Democrat, they tend to be the ones who, at least on the surface, will say they're fine with increased science funding. Is there value in telling the Republicans about a need for increased science funding, and is there value in just telling the Democrats that like you appreciate their continued support?
There is value, of course. I mean,
because I know those, like you said, it's if it's that vague, maybe it doesn't have the same impact or the same memorability.
Yeah,
but like
I think targeted blitzes are incredibly valuable,
and that's why we do these days where we're trying to send as many geoscientists to the Hill at one day as we can.
Absolutely, because then everyone is going to hear from us, and maybe someone starts talking about it.
Creates a narrative.
Yes, and it goes in conjunction with calls. It goes in conjunctions with emails. Although I kind of think emails are useless. I mean, you can delete those pretty easily.
And if you send snail mail, it could get lost in security.
Exactly. Exactly. I think a conversation with some employee of that office is critical and does make an impact. You'd be surprised how much of what happens in Congress is due to the echo chamber of what happens on that Hill.
Okay.
And not necessarily, sure, there's constituent issues, but the people who are writing and signing the bills, they're human beings, and those human beings have the thoughts that occupy their head are the ones that they hear about most frequently.
And how important is it to have these meetings just to put a face on what that legislative affairs team member or the member themselves thinks of as scientists?
I mean, otherwise we're forgotten.
Okay.
Right?
Because we don't have lobbying money. Like, we're not there. We can't go in with an offer that, like, their campaign's going to get funded because they met with us.
And it's a bizarre thing because we're essentially advocating for us to keep doing a service of the government. And in many cases, there's a party that would rather not provide as many government services. But
so when I did my congressional visit day, sorry, I cut you off.
Yeah, no.
When I did my congressional visit day, the issue that was at hand was that the House of Representatives wanted to continue funding NSF at the same level, but the thing they wanted to change was they wanted to get to decide which departments within NSF got what amount of money from that budget, which meant that they were going to cut. They were going to like probably give engineering more money to research new tech, but we're going to cut earth sciences funding because they didn't want climate change getting studied.
Right.
And so like our specific ask that we were going in the room was, while we appreciate you continuing to fund science, we would also appreciate if you let us decide the best way to allocate the funds.
Yeah, and that's the granularity that you need.
Yeah.
That's the
But I wouldn't have known that if we hadn't had a legislative affairs person from AGU to coach us through that.
Absolutely.
And even then it's super awkward and super hard because it's like, so I don't think scientists are built for these kinds of meetings.
No, there's a reason we've kind of been steamrollered in the special interests world.
Yeah.
You need to be okay with conversations, lots of them. You need to be okay with
ones that are just explicitly about what do you want?
Yeah, asking.
And that's weird.
Scientists
are not good at the ask.
No, we're kind of passive.
Yeah.
Yeah.
And we kind of just want you to accept that what we tell you is good enough.
I mean, I have the data, right?
Yeah.
That's all you need.
So if you had like one big take-home message for scientists who are interested in policy and in having a positive influence on policy, like if they can meet with a legislator, great. If they can make a phone call, great. But like, what's some of the take-home messages you wish more scientists thought about when they were complaining about funding or science policy in the U.S.?
Get informed. Honestly, I don't know as much as I should about the science issues that are at the government. The other thing that's really important, so like there are plenty of groups that are advocating for you. Get in touch with them. Like follow AGU's Facebook, follow GSA, that's Geological Society of America.
Union of Concerned Scientists.
Follow Union of Concerned Scientists or AAAS. These are organizations that actually do have a fair amount of DC experience. They know what they're doing. And they're putting out all sorts of information for you of exactly what you need to do.
So it sounds like the best thing an individual can do is hitch their wagon to an organization that they support the agenda of, and then just help.
We're used to reinventing the wheel. You don't have to do that. We've got a lot of groups in place.
I like that. Yeah. I like that. And then if there, to maybe pivot back to science before we wrap up here, is there a take-home message that you would like people to remember when thinking about your science up in the Arctic and the permafrost and the thaw?
Yeah. It's a water problem. It's you know what? It's a great project for understanding why like many different types of science need to work together, right? I need to know hydrology. I need to know climate. I need to know geochemistry in order to answer this problem.
And then you got to talk to a botanist from time to time.
And you got to talk to a botanist. Absolutely. And so I'm not an expert in any one of those fields, but I am pretty good at all of them. So you got to be okay with that. Just answer the question that's in front of you.
So people can follow along with your continued research at mtoconnor12.wixsite.com.
Thank you. Yep.
And I will put a link to that in the show notes for this episode. And one last thing I want to ask you about before we wrap up is you said that you also do some music. Is there a place people can go hear your music?
Back in Austin, go see an improv show.
All right. You do improv in Austin too. Okay.
I do the music for it.
Oh, you do the music for the improv show. So you're the Josie Lawrence. You're the like
I'm Laura Hall or whoever.
Laura Hall, Linda Taylor.
Mm-hmm.
Yep. So you're the like let's hear that classic ska anthem, AGU on the hill.
Yeah,
and then you. That's really cool. All right.
That's how I keep my sanity.
Okay, cool.
Yeah.
And so I assume if people go to your website, they can find info about upcoming shows and stuff like that.
Sure. So. Yeah.
Great. Well, Mike, thank you so much for talking with us. This was great.
You too. Thanks so much.
That was my interview with Mike. Thanks so much for chatting with me. I think I mentioned this in the interview, but I haven't actually gone back and edited that audio yet. But I think this is the first time, as much as we've joked about it in the past, that I actually did record Science Sort of in a suit and tie.
Oh,
yeah,
nice.
Because that same day that I recorded this interview, I got to say one of my favorite DC phrases, and it's that I have a meeting on the Hill, which is slang for going to Capitol Hill for a meeting.
I would have never guessed.
And because that was the day that AGU did their Geoscience Congressional Visit Day, or GeoCVD, and Mike and I were both participating in that. So Mike was actually also wearing a suit. So this was the best dressed interview that we've ever had, I think.
Have you seen the AGU headquarters near DuPont Circle?
That's their temporary one.
But they have like the planets inlaid in brass in the sidewalk in front of it, and they have like different geophysical equations inlaid in brass in the sidewalk in front of it.
Is this they're building a new headquarters right now. I don't know which one you're referring to.
The one that's been there for like 10 years.
Yeah, it's probably, yeah. They've been at a temporary headquarters for a little while.
I had a friend I was visiting in DC a few years back, and we just happened to walk right by it. I was like, he works for the State Department. I don't know what he does, but I go, oh, this is where AGU actually is? And he's like, what, you know this thing? I go, yeah. And he goes, it's some kind of cult. Like they put all these like weird symbols and planets in front of it. I'm like, yeah, it is some kind of cult. It's American Geophysical Union.
Science cult.
We're all ignorant about some things.
Oh yeah, there's no reason that anyone other than the 17,000 people that go to AGU should know what it is. That sounds sarcastic, but it's not really.
It's not really.
So with that, those are the two interviews I had for everyone for this episode. But we can't finish the show just yet because we have to do some listener feedback, and that's coming up in our final segment, the PaleoPOW. End Science Sort of the way we always end Science Sort of, with a deep and with a deep melancholy and wondering why we still do this. But we're also going to end it with some feedback from you, the listeners. Patrick, I'm gonna point at you to go first.
Okay, I will do my very best. So my understanding is that we need to give a thesis title to longtime supporter of the show and artist Sonya A. And we owe her a lot. Not only does she support the show, but back in the day she did some Brachiolope Valentine art for us. And I guess that's relevant, right? Will this episode be up in time for Valentine's Day?
That is a good question, and that was one of the things I was working on this afternoon before we started recording, and I got distracted.
That's cool.
It'll be out right after Valentine's Day.
Okay. So I'm sure as you're looking back on your Valentine's Day plans, you wish that you had known just a little bit earlier, so you could have gone and downloaded some of the Brachiolope Valentine's Day art that Sonya's done for us in the past, because that would have definitely made your Valentine's Day go a little smoother.
You can actually buy the Brachiolope Valentine from her online store, and she gives us 20% of all those sales.
See, Sonya, you're too generous. But anyway, it's time for us to bestow upon you a title. Let's see, a thesis title. So let's see. I'm inclined to want to mix in some like romantic habits of the Brachiolope.
Okay.
And let's see. We got dunes. We got
carbon sequestration in frozen soil.
All right. So like romantic.
Have we done? I feel like we've done a Brachiolope mating one before.
Well, this doesn't have to be. It doesn't have to be.
I would hate for Sonya's thesis to have been scooped.
Well, I think a lot of people are interested in the mating habits of the Brachiolope when you come to think about it. But it could just be sort of herd behavior or coupling behavior for Brachiolope podcastensis in cold weather and in sandy environments, something like that.
So we actually, I went back and looked at the list. We've never given out a Brachiolope themed thesis. This could be a first, and I think she's earned it with her multiple tributes to the Brachiolope. So, well, I was thinking maybe part of the mating ritual of the Brachiolope has to do with like airflow around the horns, creating some sort of sound, or it does kind of have it has the nose spout up by the horns. Maybe it can like vocalization. Is there a vocalization thing?
Mating call of the Brachiolope. You. Sounds like that, I think. based on the scientific reconstructions I've done.
You 3D printed the skull. Yeah. So sexual selection in the Brachiolope
and mating vocalizations.
Maybe she was testing in like tundra environments versus like dune environments.
Mm-hmm. Effects of aeolian effects in sandy and cold weather environments, cold climate environments. Did I misstep there?
No, I think you're good.
All right.
I was just typing. What do you think, Charlie? You got anything to add to that?
Well, I'm looking at the painting that Bryn made, right?
The original Peaches the Brachiolope was by Bryn. The one I just posted in the Slack chat is by Sonya, the person we're giving.
Oh, I like that one. So that one has a smaller.
It's a chupacabra.
Smaller air hole in the.
I thought you were talking about the other little creature nasal. On the.
So I wonder if there's some sexual dimorphism with the
size
air
of the
hole,
nares,
and if that affects mating sounds.
And maybe it needs the smaller nasal opening in sandy environments where it's like gonna get clogged up.
That's a good point.
Or actually
or cold environments, because you need to warm the air before it hits your lung tissue, as we've learned this week with the polar vortex in the Midwest.
But think about how far away that lung tissue is.
So what is that organ called?
Well, that's just their nasal opening on top of their head there.
Is nares the scientific name for the nasal opening?
Narial adaptation and use in mating rituals based on presence in aeolian dunes or freezing tundras across the range of the Brachiolope.
The majestic Brachiolope.
Oh, I like across the range.
Okay, Brian.
Oh, yeah, I'm trying to put it all together. Sorry.
I know. You've got it typed up there in front of you. Mix and match. And let's get this final version.
What's the scientific name you use for the Brachiolope?
Podcastensis.
Is the genus name just
right?
Brachiolope?
It's Brachiolope podcastus, I think. Is that what it says on our podcastensis? I like podcastensis.
Okay.
I like this drawing. What kind of flowers are those? Irises?
I am the wrong person to ask.
No, it's not an iris. It's like a blue lily. What the hell is that? It's beautiful, though.
What's the one?
All right, I got it.
Okay.
The only effects. All right, so I'll pass this over to you guys. If it sounds good, then we will confer it upon Sonya for all of her hard work.
The aeolian effects of sandy and tundra environments on the sexual dimorphism of the nares of Brachiolope podcastensis, implications for sexual selection and mating vocalization across climatic extremes.
Beautiful. I would doctor the out of that thesis title.
But it's not a doctorate, it's a BSSO. It's a Bachelor of Science, sort of.
Oh, well, yeah, I'd do that too.
I haven't had a chance to feature it yet, but we did get an email from somebody who has now appended, they have like an actual degree that comes with letters after the name, but they added, comma, BSSO after that when they sent their email, which was definitely points for style, for sure. All right, well, that it took us a minute to dance around it, but we figured it out. And Charlie, I think you're up next.
All right, well, sit down. This is going to be a bit of a long one. Let me do a little pre-read, make sure I don't screw this up. Okay, so this is an email from Tom. Subject, Blade Runner rules, 3 exclamation points. Message, Blade Runner rules, 3 exclamation points.
This is an older email, but it checks out because we're now living in the year that the first Blade Runner is set, which Charlie and I joked about last time, and we both immediately thought about the noodles that he's eating in one scene. and that was the most important and relevant part of Blade Runner, and not that this is the future we were promised.
And whether or not AI has conscience or a soul.
Are you actually a big fan of Blade Runner, Charlie, or do we both just like that scene with the noodles?
I actually really like Blade Runner. Yeah. I like Philip K. Dick, and I like that adaptation.
Did you like the sequel?
I like the sequel a lot, just from I like the opening scene of like
the opening scene's
the Mojave
great.
Covered with solar power towers, and then like all the climate change stuff, and then just the hyper connectivity of social media leading to like total isolation.
Yeah.
What is the like that growing trend in Japan? Hikikomori or whatever.
I've not heard of this.
I have to Google it because I don't know if I said that exactly right. Yeah, hikikomori is a psychological condition which makes people shut themselves off from society, often staying in their houses for months on end. And it's happening in the most like densely populated places in Japan. So it's this like reversion to hyper socialization. And so then they just stay inside all day, every day for months, and have their food delivered and only interact via computer.
Matrix.
Yeah, people said the new one was like slow and plotting, but I kind of think it needed that because otherwise you're not in the right mood. It's not an action movie.
It was long though. It was like 2.5 hours long.
Yeah, it was long, but I enjoyed it. I enjoyed it as well. Yeah, Patrick, what was do you have Blade Runner thoughts? I know I gave this email to Charlie, but
I mean, I would say I'm a fan. I liked it. I saw the sequel. I liked it. It doesn't sound like I'm quite on the level you guys are, but I really like some Blade Runner.
I haven't actually read the novel. I probably should add that to my...
Is it even a novel, or is it just more of a short story?
Wikipedia calls it a novel, but we've been yelled at before for getting that one wrong. It's 61,000 words, which would be considered a short novel. 210 pages. Yeah. I don't know if it's novella. I don't know what the cutoff point is. I imagine it's a fuzzy boundary. But for Philip K. Dick, who was known for his short stories, that is definitely on the longer
pretty long,
side.
Yeah.
So
it's not as memorable as the first one.
Yeah.
No.
Yeah.
I love that.
Well, I mean, I think that really was kind of a twist at the end of the first one.
Of what you don't know whether or not Deckard is a replicant?
Right. Whereas the second one, I think you pretty much went into it knowing kind of what was going on.
Yeah.
Like when that one guy dies at the end, spoiler alert, that one replicant, where he talks about like attack ships on fire off the shoulders of Orion and like C-beams glittering in the dark and stuff like that. It's like super poetic.
Teardrops in the rain.
Yeah, apparently that actor, I apologize for not knowing his name, like improvised that.
Oh, wow.
But yeah, I don't have those
Rutger
like
Hauer
sharp,
was the actor.
Those sharp images that the first one has. But I don't know. I like the second one too. Blade Runner rules, triple exclamation point.
This message approved by Charlie. All right, so for me to wrap things up, somebody sent in an email about GitHub, so I think they might have failed the Voight Comp test if we were talking about Blade Runner, because I'm not sure anyone who's passionate about GitHub is really human. But
Exactly.
I got an email from Chen R, and they said, "Hey Ryan, on episode 275, Publishing Rocks, you mentioned that you didn't get along with GitHub. I think I made some joke that one of my guests' websites was built using GitHub, which was not a thing. I think Justin does that too, so it's
not
sounds like
uncommon in academia, but it's not something I was super familiar with when we did that episode, which was, a while ago.
Some people write papers they use it for version control on their drafts. So
yeah, and I think that's
Git.
part of its, yes. But I think you are right. But to finish the email, Chen says, you are right, referring to me, Ryan. Git can be confusing as hell, and GitHub adds another layer of complexity over that. My stock advice for dealing with that confusion is the talk Git for ages 4 and up on YouTube. After that funny and delightful hour and a half, Git will still be confusing, but in a way that one can deal with. I hope you will enjoy this as much as I enjoyed listening to your podcast. Cheers, Chen. So I clicked the link because Git is something I would like to learn how to use better.
Right. Yeah.
But I feel like, I know it says ages 4 and up, but I don't have a 4-year-old. Is there attention span for YouTube videos explaining Git an hour and a half long? That seems optimistic to me.
Their attention span for watching people unbox toys is an hour and a half, so I'm not sure about Git.
Do either of you guys have to use Git or GitHub for your science?
It seems like Charlie would do this.
No, I don't know. I don't use it. I don't get it. What does version control even mean?
If you were working on a piece of software and you added some new code that broke things.
Okay, yeah, that's what I guessed.
Yeah, Git gives you a way to fork the repository, so there's if two people are working on two things separately, they're not overwriting each other's code accidentally, and it's very Silicon Valley-y. And more researchers I know who do natural science research are using GitHub. I think it's a good place to collaborate on R code if you're writing code for your papers.
On any kind of for mostly any kind of code, but I have heard that people are just writing papers on it when they collaborate so that they can merge the changes together and keep track of different versions. And I don't know, it doesn't seem like it's purpose made for that sort of thing, but maybe I'm missing something.
My feeling on Git and GitHub is it's sort of like the joke Paul made to you about LaTeX, Patrick, of it's great if you learn it, but unless your collaborators know it, who cares? So right. I feel like it's the sort of thing where if you were managing a lab and you insisted that everybody use GitHub as part of your lab management, that would be one thing, but I don't know that there's a ton of utility in the individual researcher learning it if none of their cohort, none of their advisors, none of their collaborators use it as well. I think you have to have collaborators who plug into it.
If you are writing software and you want, if sort of coding and writing software is part of your resume, I think it's essential that you have a GitHub repository that you can show to people and say, yeah, this is stuff I wrote.
I have applied for fellowships that are more data science focused, and they do ask for your GitHub username so they can go check out your public facing, GitHub stuff. So I've been learning to use it more. I haven't finished this YouTube video yet, but it seems like a tool I could find utility in, but only if it was a part of my regular routine and not just something I used every once in a while.
Right. I think that's key because I did use it for a week or two and got somewhat competent in it. And now I don't remember a single thing about it.
Right. And I finally crossed that threshold in R where now I can be away from R for a little bit and come back to it and still feel like I'm okay. Mm-hmm. And that took a while. I don't know if I've got the stamina for another fight like I had with R. R about beat me, but then I something clicked and I crossed a threshold, and now I really like R. So maybe Git's the same way.
Maybe I'm sure it is. Right.
Git, much like the vanilla version of R, there's a program you can get called Git that is just a command line based program, and that I was trying to learn once for a class and found that was what I was complaining about. GitHub seems to be a much more developed toolkit that has things I can use. So. That's my updated thoughts on Git.
Okay. Why don't you just what do they say when you submit your code to Git?
Push? Do you push it to Git?
Yeah, just push it and let's go.
Okay. Git push, Git
pull.
You
guys have sparked my curiosity. I think I'll go check it out. It sounds like it could be useful.
Charlie's going to watch this video. He's going to be using it full bore tomorrow.
Full Braven.
I don't know. The preview picture of the video shows a guy wearing an orange shirt and blue overalls. That's kind of creepy to me, but I'll click it. I won't be judgmental of poor fashion.
Well, if you have something to be judgmental about with anything we've said here in this episode or anything our guests have talked about, you can get in touch with us on our contact page at sciencesorter.com, and we're also on Twitter and Facebook. You guys heard of those? All the kids these days.
God, so many different online images to maintain. Now I got to make a Git image too.
And when are we going to get an official Instagram for the show?
Oh, that's a kind of a good question, and I just
When Facebook merges WhatsApp and Instagram and Facebook all together,
I do
which
like
they plan
WhatsApp,
to do.
But I don't think it makes sense for us to do anything on the podcast with WhatsApp.
Zuckerberg becomes president of the
No. This show is now not going to age well, Patrick. When that comes to pass. Oh, all right. Well, hopefully by the time President Zuckerberg is sworn in, we're still allowed to do this podcast and we haven't had our mics pried from our cold, dead hands. And until then, you can come back next time for AGU Part III, which I can guarantee is going to have a whole lot more science.
Sort of. Primarily it's just science.
Yeah.
Do you miss it? Do you miss the sort of? Do we need to get back to the Bigfoots?
Yeah, I miss the sort of.
Visit sciencesortof.com for show notes, links to all the stories we talked about, and ways to interact with the hosts, guests, and other listeners. Science Sort of is brought to you by the Brachiolope Media Network of podcasts, with audio engineering by Tim Dobbs of the Encyclopedia Brunch podcast. That's all for this week. See you next time on Science Sort of.
Everyone keeps saying it's colder in Chicago and Minneapolis than in Antarctica. I was like, yeah, it's summer in Antarctica.
Yeah, I think it's much more interesting to say it's colder in Chicago than the equator of Mars.
Yeah, that to me is a better metric for coldliness, but
coldliness.
I don't know.
In the absence of heatliness.
Absence of heatliness. All this cold that people are like posting about is about as cold as it would get in an average winter in Wyoming at least once.
No way, really? -40?
Not -40. It got down to -20 was the coldest day I
guess, yeah, that's what I guess. Well, part of the problem with the news right now, they keep on putting like the wind chill because it
sounds good.
More shocking, yeah.
I mean, there was usually wind in Wyoming.
Yeah.